Hi, you're about to take the AP exam for AP Chem. Here's some last-minute reminders to think about before you start the test. Here are the periodic trends. As you move right across the period, the atomic radius decreases, and as you move down the group, the atomic radius increases. The electronegativity and ionization energy increase as you go across the period and decrease going down the group. The first group has a +1 charge and the second group has a +2 charge. Skipping over the D block, the next group has +3, and then -3, -2, -1. Okay, the first mnemonic is Funkelbrich, and Funkelbrich are the most electronegative elements, starting with fluorine. Next is Fon, so hydrogen bonds can only form when the hydrogen is bonded with one of these elements, fluorine, oxygen, or nitrogen. Next is 1, 2, 3, 4 honk, so when drawing Lewis structures, hydrogen forms 1 bond, oxygen 2, nitrogen 3, and carbon 4 bonds. Finally, when in doubt, convert to moles or make an ice table. Here are the solubility rules. So NAG/SAG are always soluble: nitrates, acetates, group 1, sulfates, ammonium, and group 17. The exceptions for sulfates in group 17 are PMS, so lead, mercury, and silver, and for sulfates, Castrobare, calcium, strontium, and barium. Remember that breaking attractions requires energy, and that's an endothermic process, and forming attractions releases energy, which is exothermic. Stronger intermolecular forces make for a higher boiling point, a lower vapor pressure, and a greater viscosity. Don't forget PV equals nRT. Gases behave most ideally at high temperature and low pressure. Deviations from ideal gas law are low temperature, high pressure, when the particles are too large or too polar, and when intermolecular forces between particles warp their paths. When the graph of the concentration of A is linear, the reaction is zero order. When the graph of the natural log of the concentration of A is linear, then it's a first order reaction. And when the graph of 1 over the concentration of A is linear, it's a second order reaction. Moving into thermodynamics, when the enthalpy is positive and the delta S is positive, the reaction is favorable at high temperatures. When the delta H is negative and the delta S is positive, it's always favorable. When the delta H is positive and the delta S is negative, the reaction is never favorable. And when both are negative, the reaction is favorable at low temperatures. At equilibrium, delta G equals 0 and E equals 0. The reaction is thermodynamically favorable when delta G is less than 0, when E is greater than 0, and when K is greater than 1. Raising the temperature does not affect delta H or activation energy. Next is equilibrium. So the value of K is temperature dependent. Increasing temperature increases the rate of both the forward and reverse reactions, but increases the endothermic directions rate more. Large K means the reaction has essentially gone to completion, and vice versa. When dealing with Kp, don't use brackets because you're dealing with partial pressure and gases. Don't forget that acid plus base makes salt plus water. Bronsted lauryl acid donates a proton and the base accepts the proton. pH equals pKa at the half equivalence point, and M1V1 equals M2V2. For oxidation-reduction reactions, oxidation is loss of electrons and reduction is gain. Reduction happens at the cathode and oxidation at the anode. Voltaic cells are spontaneous, and electrolytic cells require a power source or battery. Finally, answer every question. It's in your best interest to guess rather than just not answer the multiple choice. Do the easy questions first and the more difficult ones next. Be confident and power pose before. Good luck, you're going to do great.